In section 3, we're going to look at how we can use ratios and proportions to find areas of similar figures, or find perimeters of similar figures if you know the areas, any combination of these things. So let's say I've got two similar figures. Okay, I went with the most basic similar figure, which is a square. This square has lengths of 5, so it's 5 by 5. This one is 10 by 10. So let's look at how their ratios compare. The ratio of the sides would be 5 to 10, which is a 1 to 2 ratio. The perimeter of this shape would be 5 plus 5 plus 5 plus 5, which would be 20. Perimeter of this one would be 40. So their ratio of their perimeters is also 1/2. The area of this shape is 25 units squared. The area of this is 100 units squared. Okay, length times width. So the area ratio is 25 over 100, which reduces down to 1/4. Now let's expand on this and get some numbers that aren't so easy. So something that's not a 1 to 2 ratio, and see if we can develop a pattern. So let's say instead our squares had ratios. So let's say one square had sides that were 3, and the other one had sides that were 7. So the ratio of the sides would be 3 to 7. The perimeter of a square with sides of 3 would be 3 plus 3 plus 3 plus 3, which would be 12. 7 times 4 is 28, and this is going to reduce down to 3/7. So again, the ratio of their sides and the perimeters are the same. The area of a square with sides of 3 is 9. The area of a square with sides of 7 is 49. This does not reduce. So how do I use the ratio of the sides to get ratio of area? Well, if I take the ratio of the sides and I square it, I get the ratio of the areas. Okay, and this applies to more than just squares. This is going to apply to any shape that we have. Okay, since the sides are a single measurement, they're just length, and area is the multiplication of two measures, length times width. You use a one-dimensional ratio to get to a two-dimensional ratio by squaring it. So, if I know the ratio of two similar figures, the ratio of two similar triangles is 84 to 40. What is the ratio of the lengths of the corresponding sides? This should be the ratio of the areas. Ratio of the areas of two similar triangles. So if the area ratio is 84 to 40, that means I need to go backwards. So since if I knew the ratio of the sides, okay, which I don't know, I would square it to get this. So in order to go backwards, I'm going to square root these. So let's break these down. 84 is 4 times 21. This is 2 and 2. And this is 7 and 3. 40 is 4 times 10. This is 2 and 2 and 2 and 5. So I've got 2 square root 21 over 2 square root 10. 2's cancel. The ratio of the lengths of the corresponding sides is a square root of 21 to square root of 10 ratio. Find the ratio of the area 1 to the area 2. Well, in order to find this, first of all, let's prove that these are similar. I've got vertical angles. These are parallel. So I've got congruent alternate interior angles. So by angle, I have similar triangles. Since I know that their sides are proportional. So their scale factor is 10 to 14, which reduces down to 5 to 7. This is the ratio of their sides. So the ratio of the areas is going to be 5 squared, which is 25, over 7 squared, which is 49. So let's say the area of this shape is, we'll just make something up. Try to find something that's easy. Let's see. Let's say the area of this one is 14. Okay, this is an area of 14. So what that means is 25 over 49, that's the ratio of the areas. That should equal the actual area of the small one over the actual area of the big one, which we don't know. So I can find the area of the big one now by cross multiplying. So you get 25x equals 63, no, 49. 686. And if I divide that by 25, I'll get the area of the other one. 27.44. Okay, and that would be the area of the bigger triangle. So that's why we're finding these ratios, so that we can use them to find missing areas. So if I can't calculate the area, I'm going to use ratios if I have a ratio. All right, let's say we have this floor plan, and it's a scale of 1 inch to 18 feet. So 1 inch on the drawing is 18 feet in real life. What is the scale area of the kitchen? What is the actual area? Okay, well, scale area is what's the area of the drawing of the kitchen. Okay, so let's see here. This is 1 1/4 inches. So if I take away 3/8, that will tell me what this piece is. Well, 1 1/4 is 5/4, which is really 10/8. Okay, and I want to subtract 3/8. So that would give me 7/8. So this is 7/8. This here would be the same size actually, because I'd be taking 1 1/4 minus 3/8 again. So if I take 7/8 times 7/8, that will be the area of the scale kitchen. So that's going to be 49/64. Well, if the floor plan has a scale of 1 inch to 18 feet, then the ratio of areas, okay, since the side ratio is 1 to 18, the ratio of the areas is going to be 1 squared to 18 squared, which is 1 over 18. 324. So if this is the area of the drawing, let's get a decimal here. Okay, I get that. 0.766, we'll say. Okay. And that's the small one. I should be able to take the area of the small over the area of the real should equal 1 to 324. So if I cross multiply, I'm just going to be multiplying by 324. 248 square feet on in the real house is how big the kitchen would be. Okay, so 248. This is 0.766. What's the scale area of the bedroom? Here's the bedroom. It's 3/8 by 7/8. Should be 21/64, which is 0.328. And again, if I take the area of the picture bedroom over the actual bedroom, that should be a ratio of 1 to 324. So the actual bedroom is 106.3 square feet. Okay, and you'll have a similar problem like this in your packet. Okay, so that's how you can use ratios to get area ratios. Just a note, this can be expanded to volume too. If we had a solid cube, okay, not a very good cube, but if you had a cube and each side was, you know, 5, and then we had another one whose sides were 8, the side ratios would be 5 to 8. And to get the volume ratios, I would cube these because volume is length times width times depth. So you'd have 125 over, let's see, 512. And that'd be your volume ratio. Okay,